Okay. Here's a triangle that I want us to solve. A is 60 degrees, B is 20, C is 30. Well, can we solve it with the tools that we have? Why? Okay, that angle is in between our two sides. Notice for the log signs that we have to have at least an angle side pair, right? This side, we don't know the angle. This angle, we don't know the side. This side, we don't know the angle. Okay, so this is not going to work. We need another set of tools, which is why we're going to talk about the law of cosines today. Okay? If you recall from Algebra 2, this is the law of cosines. Okay? Do you need to write all three of these down? No, pick one. Okay? Basically, we have a side squared equals another side squared, the second side squared plus the third side squared, minus 2 times those two sides, times the cosine of the angle that matches this side over here. Okay? So just write down one of these and know that whatever side is lonely over here, that's the angle in your cosine. Okay? Do you remember the times where we can use the law of sines? I'm sorry, law of cosines. Law of cosines. Okay, so when the angle's in between, and there's one other time. Side, side, side. Okay? If you're presented with a triangle with side angle side or side side side, we have to use the law of cosines. Okay? From there we can make some decisions, but we have to start with the law of cosines. Alright? So, let's solve that. Solve this triangle. Alright, so we know side angle side, which means we need to use the law of cosines. Okay? In the law of cosines, how many sides are used for the formula? Well, in the formula, all three sides are present, correct? Okay, so if I'm missing a side, that's the first thing that we need to find. Right? So, our law of cosines formula, a squared is b squared plus c squared minus 2 times a times c times the cosine of a. Okay. Well, this is nice, isn't it? Okay. All you have to do is plug this into your calculator right here, right? And then do what with it? Take the square root. What do we get?
all we had to do.
Well, we have to solve the entire triangle. Okay? So now, what do we need to do? Okay, you can switch to the law of sines, or you could continue with the law of cosines. Now, here is my warning about switching to the law of sines. Okay. Technically, we can use the law of sines now because we have side-side angle, right? But when we have side-side angle, we have that ambiguous case, correct? Now, if you start out with the law of cosines, you will never have a second triangle. However, you need to make sure that your triangle makes sense. Okay? So would you guys like to switch to the law of sines at this point? We don't have to consider the second triangle, but if our triangle doesn't make sense, we will have to adjust our angles. Okay? So let me show you what I'm talking about here. Okay? What angle would you want to find first after this? What? Okay? I would always go for the biggest. Okay? So you want to find angle C? So the sine of angle C over 10 equals the sine of 55 over 8.64. Which means the sine of angle C is 10 times the sine of 55 degrees over 8.64. You're taking the inverse sine to get C, correct? And what do we get? Which would make angle B what? Is our biggest angle across from our biggest side, smallest angle across from its smallest side. However, something bothers me. This is an angle of 55 degrees, and this has a side of 8.63. This is an angle of 53 degrees, pretty darn close, right? And this has a side of 3. Does that bother anybody else? No? Does that make sense in a triangle? No. Does our triangle really make sense here? No. Okay. So, if our triangle does not make sense, okay, what has to happen then? Because, okay, these are almost the same, right? And in an isosceles triangle, you have sides opposite that would be the same, correct? This is all pretty darn close to being isosceles. And B is 3, A is, okay, that's not okay. So, this is good. I'm glad we picked angle C first. Since we switched to the log signs, using the ambiguous case, our triangle doesn't make sense, right? So instead of 71.46 degrees, what other angle would satisfy this right here? (108.1) which would make angle B this look a little better. This looks a little bit more proportional, doesn't it? Okay. If your triangle doesn't make sense after you switch to the log signs, then you need to go back and you need to pick the obtuse angle instead of the acute angle. Okay? Now, if you don't want to have to worry about that, then you can use the log cosines for the entire problem. Okay? And that's okay. So that's up to you. All right? Is the log signs easier? Yes. However, you run the risk of the ambiguous case. Okay? Log cosines, a little bit more involved with the formula. However, it will give you the right answer every time. Okay? You won't have to think about whether your triangle makes sense or not. Yes?
It doesn't make sense, so why does it work mathematically?
Because this, remember how we talked about the sign is positive in the first and the second quadrant? Right? And so this ratio, there is a triangle that in the first quadrant that satisfies and the second quadrant that satisfies. Your calculator is only going to give you the one in the first quadrant, right? When we push inverse sine in our calculator, it's only going to give us angles between negative 90 and 90 degrees, okay? So mathematically, there are two different angles that could be in a triangle. And so we get the acute angle. If that doesn't work, then we have to pick the obtuse angle. Does that make sense? Okay. If you don't want to have to worry about it, stick with the log cosines the entire time. All right? Okay. Here is our side, side, side example. All right. My suggestion would always be to start with the biggest angle, and then you could avoid the ambiguous case if you switch to the log sides. Okay. In your side, side, side case, I would start with the biggest side. That way, if it's obtuse, then your ambiguous case you wouldn't have to worry about. So, let's start with angle A. Our formula: A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Please be careful with your order of operations. Okay? What is 34 squared? What? 1,000 1,056. Okay, what? 1,156. All right, over here, what can we actually like put together? Can we do 20 squared plus 18 squared? Okay, what is that? What did you say?
720.
Okay, thank you. Minus, what's 2 times 20 times 18? This one's 720, okay. Times the cosine of A. Please be careful. Can we subtract those two numbers? No, we cannot subtract those two numbers. What do we have to do? Subtract the 724, so we get 332? No, 432. Okay. Then what? Yep. So you have the cosine of A is 432 divided by negative 720. So now we have the cosine of an angle. We want the angle, not the cosine. So take the inverse cosine to find that angle. Okay. All right. So now we have two more angles. We can continue to use the law of cosines. However, we do have a side-side angle here. We could switch to the law of sines. What would you like to do? Stick with cosines? All right, what do you want to find next?
B.
Angle B. So for angle B, we need to take side B squared equals side A squared plus side C squared minus 2 times side A times side C times the cosine of angle B. All right, 20 squared is 400. What's 34 squared plus 18 squared? Minus 2 times 34 times 18. 1,224. So then we can subtract the 1,480. And then divide by the negative 1,224. $28.07. Okay, does everyone agree? Your calculator is getting the same. Some of you are so deep in your work. 28.07. All right. So angle A is 126.87. Angle B 28.07. Subtract those from 180 to make angle C. Okay. My advice to you, if you would like to use the law of sines after you use the law of cosines once, if it's side, 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 start with the biggest side. If it's side, angle, side, when you go to find your angles, go to the smallest angle. Okay. If you want to just use the law of cosines all the way through, then you don't have to worry about the ambiguous case, and that's awesome. Okay. There's one more thing I want to talk about. It is a formula for area that you used last year, but for some reason, it's confusing for some kids. So I want to talk about it. The law of sines area formula is pretty simple. This one, we have a couple things to remember. All right. This is Huron's formula. When we know 3 sides of a triangle, we can use this. Okay. Our area, I don't know why big S is area, but so this is our area formula, the square root of S times S minus A times S minus B times S minus C, where this is S. Okay, so write it down and then we'll do an example, okay? Okay, so if you know 3 sides of a triangle, we can find the area. We don't have to worry about 1/2 base times height, okay? So the first thing we would need to do is find S. S is 1/2 times the sum of all 3 of your sides. Okay, so these numbers are kind of big. So 152? No, 252? 126. Okay. What? Wait, was 126 the sum or? Okay. I'm talking about the sum. The sum was 252. Okay. Cut in half is 126. All right. So then that's our little S. So our area is going to be the square root of S times S minus each side. So S minus 43 times S minus 89 times S minus 120. Okay? You can find each of those differences, or you can just plug it into your calculator like it is right here. Just be careful with all of your parentheses.
Should we do everything within the square root first and square root it?
You can put it in all at the same time. You can say, here, let me get my calculator. My calculator, and I can just show you here. Where's my mouse? Where's okay, well, so we can do the square root of, what was it, 126?
Yeah.
And then parentheses, 126 minus, give me a second, 43. Close your parentheses. Open parentheses. 126 minus 89. Close your parentheses. Open them back up. 126 minus
120.
so 1,523.7 unit square, right? When we're talking about area, we're talking about square units. Okay, so if it gives you your unit, make sure you write that unit squared. All right. Not so bad. You just have a few things to remember with that formula. Okay. So your homework is here. What I'd like you to notice is that tomorrow we are going to review our log sines and log cosines together. Basically, I'm going to give you a triangle. You're going to have to make the decision, which formula do I use, and solve it. Okay? We're going to have a quiz on Monday. I don't like Monday quizzes just as much as you don't like them, but with the snow days, I can't really avoid it. Okay? It's either we have a Monday quiz or we have a Monday test. The Monday quiz, okay. All right.
Go ahead.